So I ended the last video by doing some calculations, looking at how to calculate the number of neutrons given a mass number. So the examples that I did were carbon 12 and carbon 14. So the 12 and the 14 were the mass number, and we know that the number of protons was 6 because of the atomic number. And therefore, we could figure out the number of neutrons because the neutrons plus protons equals the mass number. So carbon 12 had 6 neutrons, and carbon 14 had 8 neutrons. So what I'm going to talk about is why do they have different masses and what do we call them? So an atom of the same element that has a different number of neutrons and therefore a different mass is called an isotope. So they weigh more because of the extra neutrons. So the example I have here is carbon 12 and carbon 14. Now, if we look at the number on the periodic table, we see that that's not a whole number. That is the atomic mass. The atomic mass gives you the average of all of the isotopes found on Earth. So we can see here that the average is 12.011, and if we look at the periodic table, you can see that none of those numbers are whole numbers. Now, if we wanted to ask ourselves, well, what is the most common, we could just round that number to the nearest whole number, and that's the one that would have been averaged in the most in the set. So, like sodium here. Sodium has an average of 22.99. That means the most common isotope would be sodium 23. Okay, or boron has an atomic mass of 10.8, so the most common would be boron 11. Now, if we look at neon here, I want to kind of point that out because I'm going to do an example with a calculation. So neon is 20.2 roughly. So I'm going to do an example under the Elmo of this sort of calculation, how we figured this out. Okay, so again, I just pulled this off of the periodic table. So neon is number 10 on the periodic table, and it has an atomic mass or an average of about 20.2. So let's say I was to take a sample of neon atoms that I found on the Earth, and I just wanted to count them up and figure out, well, what was the average atomic mass? So when I do that, I pull out and I count. I pulled out 10 atoms, and if I go ahead and I look at them, I have 8 of them that have a mass of 20. Okay, so if the mass number is 20, remember A equals Z plus N. This is just a little quick review. So remember, if it's 20 is equal to 10 protons plus how many neutrons? That means each one of these has 10 neutrons, right? Over here, because we've got neon 21, that means it has a mass number of 21. It's got 10 protons, so that means the number of neutrons must be 11. Right? But how do we figure out the weighted average? So an average of anything is just you add up all of the parts and then you divide by how many you have. So we're going to add up all of the masses of the neon 20s and all of the masses of the neon 21s. And then we're going to divide by the number of masses I added up. So I have a total of 10, and the first 8 over here are 20. So to get the total mass of all those, I just take 20 times 8. And then to it, I'm going to add the mass of the neon 21s. So I've got 21 times 2. And that will give me the total mass of my entire sample. So here, this is 160, this is 42. So my total mass of everything is going to be 202. So if I want to figure out the average then I divide by the number of parts. So I added up a total of 10 parts, so I'm going to divide it by 10. So that means my weighted average of the mass of all of these is 20.2. So that's where that number comes from on the periodic table. So remember the difference between mass number and atomic mass. So let's just look here very quickly. So we can see here, see if we get the PowerPoint to come up, that the atomic mass is the weighted average from the periodic table, and mass number is the mass of one specific element. So when we represent isotopes, there's 2 different notations that we can use. This one I've already been showing you, right? Where it gives you the symbol, and then there's a dash, and it tells you the mass number of that specific isotope. But there's another kind of notation that's called nuclear notation. So you have to be able to recognize and express different isotopes in both ways. So nuclear notation, you put the symbol off to the right-hand side, you put the atomic number down to the left, and then up at the top you put the mass number for that element. So we'll practice that in the lab and get used to using both of those notations and being able to interpret it in terms of numbers of subatomic particles.